All right, we're going to take another stab here and kind of show you graphically what's going on in some of these problems that you're solving reactions for. You concentrate a little bit on the reactions because you can see those. You can think of them as being external to your structure, but in all reality, there's a contact point there, as you'll see in an inventor, and so there really is no internal or external. And the graphics of moments and torques is important stuff to start to see, especially if you are going to slide away from the fact that you can, do a lot of this basic work in your calculator and slide towards trusting machines to do stuff. So what I'm going to do is sketch out real quick here in this tool called geometer sketchpad. That problem that looks a little bit like this, and there'll be no numbers again because these are concepts. And it's actually geometry that we're dealing with. So we've got something here. We had basically some sort of beam that did something like this. All right, so that's what the beam looked like. Now, conceptually then, what we have is we can go ahead and we can put a point here, more or less, right there, and a point there. So that's basically our beam, right? And that beam actually had a force coming down to it that was going from here. And there was a force, and I'm just going to do the force somewhat straight down. The force was someplace onto that, and so I'm going to go ahead and draft the line that is the force. It goes from there to there. And you'll see conceptually now that as this thing moves along here, right, the force can change. And so it really makes no difference what's going on here. And what we'll do then is calculate what is the reaction at this point, right? At that point, because we know the direction of the reaction because of this roller joint there. And so I'm going to show you how you go about drafting that. I think you can just grab the point and the line. I'm holding the shift key here, and I can construct a perpendicular line. So we've got a couple perpendicular lines there, if you would. I actually don't want that one, so I'm going to go edit that one and cut it. So we've got actually a line, and we know that's the direction of the reaction to this force. Now, what we are going to see is that this reactive force, which is perpendicular to the point of contact, because this is not a pin joint, this is a roller joint, this reactive force is going to react to this force here, but it's not actually reacting to the force. It is reacting to the moment about some logical spinny point, said spinny point being right here. So we then look at what is the reaction, or what is the moment, and in this moment, if you think about it, is R cross F. And so in all reality, it'd be much nicer if I were to just go ahead and draft a line that is this distance and show the force coming down here. So I will do that. I will take here and I will draw a line that basically goes down here, right? There's the line. So that's a line. Line segment. I'm going to go ahead and draft a line that's over the top here, right? And so you can kind of grab, that this is pushing on there, but you can use the rule of transmissivity. What I can do is I can grab that point and grab that little line segment, and I can now construct a circle by center radius, and I get then a point down here, which is now essentially my force. So my force is, I'm going to draft the line segment, the idea there of rule of transmissibility, I'm going to go ahead and do that, and I'll make that heavy in a second. It goes from there to there. And I'm going to go ahead and change my display on that. We're going to go with a color. We'll make that a green force. All right, and in reality here now, I'm going to get rid of this. Sorry, I'm clicking that. I'm going to take this, and I'm holding this here. I'm going to get rid of that, and I'm going to say display hide the circle. So what we have in fact here, and I'm really going to actually get rid of that, display hide the segment. So what we have now is in effect a radial vector here and a force vector here, and we know the concepts of force times orthogonal distance and the concept of moment is the area of the parallelogram formed by the radial vector, which I'll sketch now with a marker tool. That's my radial vector, and my force vector, which is here. Now, because this is a 2D problem, again, you know that it's going to be, in this case, negative going into the board, but its value is actually a geometric value. And so we get its value by taking this line here and this point there and construct a parallel line. And then we take the end of the value basically here by selecting this point and this line and constructing a parallel line, and then constructing a point, if you would, right at the intersection of the two, and then realizing that we can use a polygon tool to draft, in essence, and I go back to the beginning here, draft in essence what is the moment of this force. So as I go ahead and make this bigger, right, or turn it, that area is going to be the moment of that force. Now all we got to do and determine the reaction at here is take that moment and divide it by this area. So let's go about and do some labeling here. I can grab that and measure and give it its area. That's going to give me the area there. I can grab this long line here and that long line here and measure it and get the length of the line. And then we can actually get the magnitude of the force, if you would, reacting at E by taking one divided by the other. So in this program we grab that and we grab this and we do a calculate. We grab the value for the area, we divide it by the area value for the length, and we get that value there, 0.85 centimeters. Again, the units don't mean a whole lot here. And now we can grab this magnitude of the force, if you would, and that point right there and construct a circle by center radius, and then put a point at the intersection, and then draw a line segment from there to there, right? And we can now hide a couple of things. Hide that one there, basically. We can hide a bunch of things. We can hide this one here. We can hide this one here. We can actually hide this one here. And we can then display hide your objects. We probably didn't want to hide that one. I'm going to go ahead and draft a line segment from there to there. And now you'll notice as I go ahead and change kind of the force definition, even by sliding this up and out, right, that reactive force is going to change based on the other one. And so that, in effect, on the theory being, if it is all the way out on the edge and perpendicular, it's going to be equal and opposite. As I slide this back, all right, I guess I can't, if I slide that back, you see that that reaction goes to 0. And so that, in effect, is what's happening in a 2D sense when we start talking about, right, talking about reactive forces. It's force times distance equals force times distance. What kind of distance? Orthogonal distance. R cross F is a 3D concept. The moment or the cross product is the area defined by the radial vector and the force vector. You tend to draft in the right direction, right? If you're looking at the radial vector of force BC, you draft from A to B with your arm, and BC is how you draft the force vector. If you're looking at the radial vector of AE, you draft with your arm AE, and of course the force is going up the other direction, equal and opposite. This is a program called Geometer Sketchpad. $30 for 3 seats in your home. I don't expect that you will get it. I would recommend that you keep your eye out on how many things you see demonstrated like this when you get into structures, and many other things that are not algebraic, they are not geometric, they are based in reality. And so learning how to look at structures in terms of rotation, sense in terms of your field sense of it, and then also trusting the mathematics that you'll see with Mathematica, with Geometer Sketchpad and the like, will make you a much more versatile problem solver. So that's how that first problem, how you solve for the reaction geometrically for that end. And we'll look at a couple more problems as well. This, of course, is using Geometer Sketchpad. Thanks for listening.